Today I'm running through the ZCU111 starter design called Mini Play Capture 128K 2019.1. The PDF that comes with it is great, with all the steps that I'm about to walk through. I'll be speeding up a lot of the slow parts thanks to the magic of editing, so that you don't have to sit through them. The version of the starter design that I downloaded is RevC, and I've placed the files at the location instructed in the design documentation. There are quite a few starter designs available in the lounge. I chose this one for its simplicity, and because it doesn't need any additional equipment beyond what came in the ZCU111 starter kit. This design streams from 128K URAM out the DAC channel 7, and then back in through the ADC channel 0 into 128K of VRAM. I set up the board with the XM500 FMC by following the instructions on the XTP518 ZCU111 software install and board setup tutorial. One part that I wanted to make sure about was connecting DAC7 to ADC0. The photo in the starter design documentation has DAC7 and ADC0 clearly labeled on the XM500, but the documentation is featuring a RevB XM500, which would have been a pre-production version. The Rev 1.0 version that's in my kit is labeled DAC 229 Tile 1 Channel 3 and ADC 224 Tile 0 Channel 0 on the connectors in those physical positions. So I wanted to make sure those are still the connectors for DAC7 and ADC0. I checked J6 and J4 in the XM500 schematic and confirmed that's the case. So I have my board set up now with DAC7 connected to ADC0. The ZCU111 switch 6 is set for JTAG boot mode, and I have connected the USB cable for JTAG, PS UART, and system controller UART access. I'm going to set up my terminal program. I use PuTTY. If you don't have one installed already, refer to Xilinx UG1036 for instructions on how to install a terminal program. To figure out which COM port to connect to, I opened the device manager on my laptop and then observed which COM ports appear when I plug in the USB cable that's attached to the ZCU111. COM 5, 6, and 7 appear. I'm not sure which one will have the output, so I'll connect a PuTTY instance to each. I've got a saved session for COM 5. For UltraScale Plus devices, we want a baud rate of 115/200. And now we'll do COM 6, and then COM 7. Now let's build the hardware design. I'm going to extract the vv.xpr zip file. Make sure to extract vv directly here and not in a subdirectory. Now I'm going to the vv directory and double-clicking on vv.xpr to open the design in Vivado 2019.1. Now I'll click on Generate Bitstream and answer yes when asked if I want to launch synthesis and implementation, and click OK for the defaults. Now that bitstream generation is done, I'm going to choose Open Hardware Manager. Then I'll power up my board. Next, I'll click on Open Target, then Auto Connect. Next, I'll click on Program Device and go with the defaults, and hit the Program button. Once programmed, you'll see the Hardware VIOs tab here. Notice that the two clock signals have no activity right now. Next, I'm going to export the hardware platform by going to File, Export, Export Hardware. I'm going to make sure to include the bitstream and click OK. Next, I'm going to build the software. I'm going to launch Sdk from Vivado by going to File, Launch Sdk, and go with the defaults. It pops up the screen that makes it look like I need to take action, but fortunately, the design documentation warns me that the hardware import happens automatically. Sure enough, here's a message box telling us that stuff is happening. Next, I'm going to import the Sdk project. Earlier, we imported stuff about the hardware. Now we're importing software stuff. I'm clicking on General, Existing Projects into Workspace, and clicking Next. Then I'm going to choose Select Archive File and browse to the Sdk Project zip file and hit Finish. Okay, now we have Hello Clocks and Hello Clocks BSP in the Project Explorer. Next, I'm going to build the Sdk project by going to Project, Build All. Okay, success. Next, I'm going to run the software application using System Debugger. I'm going to the Run menu, then Run and Launch on Hardware, System Debugger. Okay. Let's go back and look at our hardware_VIOs in Vivado. You can see one of the clocks is showing activity. And in COM5, we've got output from the application. And in hardware VIOs, we see both clocks have activity now. So the application tells us to open XSCT to run commands. I'll go to SDK, open XSCT, and make it bigger. I'm going to change to our work directory in XSCT. Now we'll need some data for our DAC to output. My day-to-day work doesn't typically involve computational mathematics, so I haven't invested in a MATLAB license. For this quick demo, I just downloaded GNU Octave. The starter design comes with these MATLAB and Octave scripts. Let's open the export one for Octave. I'm going to run it. So we've got this 100 MHz waveform now. You can see the spike on the FFT at 100 MHz. Next, let's take a look at the Tickle Script that we'll use to push the data to the hardware. The capture is going into cap.bin, so let's get rid of this one that's lying around. Now we'll source run_cap.tickle. Let's look at what the hardware ILA captured. We'll make this bigger, then right-click on T-Data and make sure the waveform style is analog and the radix is signed decimal. I'll hit the play button to capture and zoom into our waveform. Okay, now before we look at the data that got pulled out of the BRAM, let's close these old windows and the export script. Let's open the import script and run that. And we've got our 100 MHz signal back. Okay, so back to SDK for some peeking at registers. The system.hdf has the address map for the PS. If we do targets in XSCT, that will show us that Cortex A53.0 is running. And we can read some registers. We'll read ADC0 current state, DAC7 current state, and we can look at the master reset register for ADC0 and DAC7. And they match the values in our application output of both Fs and both zeros. Once you launch out on your own, It's common to have questions or to need to do some troubleshooting. I would check back at the lounge to see if the starter design has any updates, or if any new ones have been posted. I've noticed that they've been getting updated and some new ones were posted between when I signed up and now. Another handy resource is the Xilinx Forums. This is the URL for the one where RFSoC questions get posted. I've put the URL in the description below for easier copying and pasting. You can see here that there are some questions about the ZCU111 that have check marks, indicating that the questions have solutions. If you find these step-by-step walkthroughs helpful, please subscribe to the Kestrel OmniTech YouTube channel to get notified when I post new videos. Thanks for watching.